Okay, for the next section that we have here, 2.3, it's called simplest form of a fraction. So what we're trying to do here, when it says to simplify, all we really want to do is we want to reduce our fractions. So I'm going to look at my first problem here, 9 over 15. Is there a number that's common both to 9 and to 15? Yeah, I know I can divide them both by 3. So 3 goes into 9 3 times. 3 goes into 15 5 times. Now I can't reduce those any further. There's no other number common to 3 and 5 other than 1, so I'm done at that stage. Now for my next part, 14 and 21. Now if you're having trouble with something like this, trying to figure out what numbers go both into 14 and 21, what you can do is you can look at your multiplication table. Here it is. And what I like to do is I'd like to look either at a row going up and down, like, or a row going left and right. Now I want you to notice right here, there's 14 and there's 21. They're both divisible by 7. Okay, so now what I can say is, okay, well, 7 goes into 14. Oops, let me get my pen again. 7 goes into 14 2 times. 7 goes into 21 3 times. Your multiplication table is going to be real handy with this here. Calculators work great, but I think multiplication tables work better because it's visual. You can see exactly what's going on. Now, for the next problem here, remember, this is what we call an improper fraction because my number on the top is bigger than my number on the bottom. Now, I might struggle here with, well, my table isn't big enough to tell me what numbers go into both 42 and 28. But because 42 and 28 are both even, I know I can divide them both by 2. So 2 goes into 42 21 times. 2 goes into 28 14 times. Now this looks very similar to the problem we just did. The only thing is the numbers are reversed. So I know I can still divide them both by 7. 7 goes into 21 3 times. 7 goes into 14 2 times. And I'm done. So now let's take a look at the next problem that I have here. 75 and 100. I can think about this in terms of money. Think about it, 75 cents and $1. So how many quarters do you need to get 75 cents? 3. How many quarters do we need to get $1? 4. 36 over 45. Again, if I look at my table, go back to your table, take a look at it. Is there a number that in the same column you see 36 and 45? If you take a look at the 9s, you'll notice that 9 goes into 36 4 times, and 9 goes into 45 5 times. Okay, so for my next problem here, 36 and 144. Again, I can look at my table, I can go slow. I'm going to go ahead and go slow on this one. So I might say, well, look, both those numbers are even. Let me divide them both by 2. Okay, so 18, half of 144 should be something like 72. My numbers are still even, so I'm going to divide them by 2 again. That's 9 and 36. Now, 9 isn't even, so if I can't go by 2, I might try my next one. Let me try 3. Well, 3 goes into 9 3 times. 3 goes into 36 12 times. I can divide them both by 3 again. 3 goes into 3 once, and 3 goes into 144 4 times. And there's my answer. Now, if you wanted to, you could have divided them both by 36. 36 goes into 36 once. 36 goes into 144 4 times. But what I want to point out is you don't have to do it in one stage. You can just keep going until you get it done. And so for my next problem here, 12 over 84, again, I'm going to do the same thing. I'm going to divide them both by 2. So that's 6 and 42. I'll divide them by 2 again. That's 3 and 21. I can't divide them by 2 anymore, so I'll try my next prime number, which is 3. 3 goes into 3 once. 3 goes into 21 7 times. Okay, so the next problem that I have here is we're still reducing 21 over 25. Now, if you look at your multiplication table and you say, okay, is there a row or a column where I see both the numbers of 21 and 25? You'll notice that you don't. So 21 and 25 is already reduced. We cannot reduce it anymore. So that stays as 21 over 25. Okay, so for the next part that I have here, we're going to talk about equivalent fractions. And it says to determine if the following pairs of fractions are equivalent. Well, the way we determine whether or not a pair of fractions are equivalent is we're going to cross multiply. So I'm going to take 3 times 10. Well, 3 times 10 is going to give me 30. Now I'm going to take 6 times 5. Well, that's also going to give me 30. And since those two numbers are equal, then we will say that these two fractions here are equivalent. So I want you to notice I'm not writing a fraction anymore. I'm writing out my two numbers, and if they happen to be equal, they're equivalent. Now I'm going to try the next problem over here. So 7 times 8, I know that's 56. And 11 times 5 is 55. Now those two numbers are not equal. So these fractions here are not equivalent. I'm going to give you some time to check these two here. Okay, so here, if you multiply 10 times 9, you should get 90. 15 times 6 should also give you 90, which tells me that these two fractions are equivalent. And over here on this next one, if I take 8 times 24, I'm coming up with 192. If I take 18 times 12, I'm coming up with 216, which tells me that these are not equivalent. All right, and so for the next part here, it says a work shift for an employee at McDonald's consists of 8 hours. What fraction of the employee's work shift is represented by 2 hours? Okay, so anytime I have a word problem like this, my first step is I really need to read through the problem. Number one, I notice it's asking me to write a fraction. So my first step is I'm going to write a fraction. It tells me that a person normally works a total of 8 hours. This particular shift, they have only worked 2 hours. So there's my fraction, but because I can reduce 2 over 8, I'm going to go ahead and do that. That's going to leave me with 1/4. The next problem, very similar. It says that there are 5,280 feet in a mile. What fraction of the mile is represented by 2,640 feet? Okay, so I know that there's typically 5,280 feet in a mile. Right now we have only gone through 2,640. I need to reduce this fraction. If I divide them both by 10, essentially what I'm doing is canceling out those zeros. Now I have 264 over 528. I'm going to go ahead and take those two numbers now, and I'm going to divide them out. I'll go ahead and divide them both by 2 because I know I can. They're both even. So 264 by 2 is 132. 528 divided by 2 is going to leave me with 264. Now, I know I can keep reducing these numbers here. Oh, let me try by 2 again. So 132 divided by 2 is 66. 264 divided by 2, I already know is 132. So I can keep reducing these out. And if I keep reducing them out and keep dividing, I can go by 6. That's going to give me 11. 132 divided by 6 is going to give me with 22. And 11 goes in 11 once, and 11 goes in 22 2 times, and there's my fraction, 1/2. All right, the last problem I have here out of 2.3 says the outer wall of the Pentagon is 24 inches wide. 10 inches is concrete, 8 inches is brick, 6 inches is limestone. What fraction of the wall is concrete? Okay, the first thing I know is that the whole wall is 24 inches wide. So there's my base number. It says what fraction of the wall is concrete? Well, it tells me right here, 10 of those inches are concrete. All I'm going to do is divide them again. I can divide them both by 2. 2 goes into 10 5 times, and 2 goes into 24 12 times. And now I'm done.